This is a video for question 19 on page 326 of the textbook. That image has been uploaded to Google Classroom. So we have a pulley system with two masses off the side, and we're looking for one, the moment of inertia of the pulley itself. Again, it's rotating about the center point, and this will be spinning anti-clockwise, meaning that the 2 kg will go downwards and the 1 kg will go upwards. So to get the moment of inertia, we know the mass is 400 grams. That's 400 over 1,000 or 4 over 10. We know the radius is 20 centimeters, so 20 over 100 or 2 over 10. And when you work that out, it's 0.04 kilograms meters squared. The second thing we're asked for is what is the acceleration of the system here, of the two particles. And because they're connected, the acceleration will be the same. So I've got two instances. This is at the start, and then after a time t, the 2 kg is after falling through a height, and the 1 kg is after rising through the same height. And because we're dealing with moment of inertia, the only way that this pulley can rotate is if it experiences a net force causing an anti-clockwise rotation. So what that means is there's a tension there and a tension there that are not equal, because if they were equal, there'd be no rotation. The tension there must be greater than the tension there. So it's not a connected particles question anymore, and one of the two ways of doing it are using energy methods. So what we do is we say that the energy lost equals the energy gained, and then we look at what loses the energy. So the 2 kg falls, so it's losing potential energy. As a result of the 2 kg falling, the 1 kg rises, so it's going to gain potential energy. And what also is happening is because that's falling, the pulley has gained rotational kinetic energy, but also each of those particles are moving in a straight line. They're moving, so they have kinetic energy, and because they're moving in a straight line, we use a half mv squared for the energy equation. So again, that's summarized. The 2 kg falls through a height, the 1 kg rises through a height, and then both the 1 kg and 2 kg are moving at the same velocity in opposite directions, but they're moving linearly, so we apply the formula for linear kinetic energy there. And the pulley is rotating, so we apply the formula for rotational kinetic energy there. You fill in your values, so 2gh and 1gh. When we bring that over, we'll get the gh there. That's a half v squared, that's v squared, and then all of this, instead of putting in the 0.04, I put in the half mr squared. A half will be multiplied by the other half that's there, so that will be a quarter in a moment. Multiplied by 400 grams, so that's 400 over 1,000 or 4/10. And then I've not put in the r because we know that v is equal to rw. So r squared w squared, which is what I have there, is equal to v squared, which is why I get a 1/10 of v squared from that last part there. So we're looking for v to start off with, and v works out as root 5gh over 8. So that's the speed of the two particles at any height along their motion. We're not looking for the velocity though, we're looking for the acceleration. So v squared is u squared plus 2as. Starts from rest, we're looking for a. V squared is that thing squared, and s is the height it falls through. So the 2h's cancel, and I get a is equal to 5g over 16. So that's the first two parts done. The final part then is to calculate the tension in each string. So like I said, the pulley rotates as opposed to a connected particle pulley where slipping occurs without friction over the pulley. So the pulley rotates, so the tensions on either side of the pulley are not equal. And if we get an anti-clockwise rotation, T1 will have to be equal to T2. We'll show that in a moment. Now you can apply the connected motions method to it. So on the left-hand side, I've said that there's a T1 up and the mass is 2, so it's 2g downwards. We already know the acceleration. So that minus that is equal to mass by acceleration. That's the first formula. Solve that and we get 11g over 8 newtons for T1, which I've written like that, just to compare it to the second tension. So 22g over 16. Repeat that for the other block, and we get T2 is equal to 21g over 16. And like I said previously, T1 has to be greater than T2 to cause that rotation. And we can see there that the T1 is slightly bigger than T2. Okay.